Hello, I'm Mike Cagle, and I've been with JM for 32 years. I'm the business segment manager in our OEM group with responsibility for our office interior product lines. So let's talk about sound control. As Sean mentioned earlier, open offices are becoming a very common theme in the commercial building industry, and that's understandable. They are more affordable and help create a sense of openness that can be appealing to many. However, they do come with challenges, one of them being sound control. In the next part of this presentation, we'll dive into the importance of sound control and how you can use insulation to tackle it. A common measurement presented for acoustical materials is the noise reduction coefficient, NRC. This is a measure of a material's effectiveness in absorbing sound in a space and is measured according to ASTM C423. It's an average across 250, 500, 1000, and 2000 hertz performance. The NRC is in place, like an R value, to help give us a unit of measure with which we can compare the acoustical performance of various materials. As you look at controlling noise levels in any given space, adding more absorptive materials reduces the reverberation time in a room and can also lower the overall noise level. When we look at the NRC ratings specifically, they typically range between 0 and 1, where 0 is for a product that does not absorb any sound, to 1 where the material absorbs all of the sound that reaches it. The higher the NRC rating for a material, the better it will be at absorbing sound across the typical speech frequency range. You may occasionally see an NRC rating that exceeds 1, but this is a result of how the material is tested. I should mention here that architects or designers may work with STC, or Sound Transmission Class ratings. STC ratings refer to how well a building partition prevents sound from traveling between rooms. It measures the reduction in noise between two rooms in decibels. One of the most important distinctions of an STC rating is that it measures the acoustical performance of the entire wall or floor system, the studs, the drywall, and the insulation as a whole, not just its individual components. In contrast, a noise reduction coefficient rating relates specifically to a single material's ability to absorb sound in a space. For practical use, NRC ratings can help building designers evaluate and compare materials to determine which materials are best suited to reducing or preventing sound transmission in their applications. To get an idea of the types of materials that can influence sound or sound control, we put together this chart to serve as an example. Keep in mind that this is an example for comparison only. Varying materials from different manufacturers may produce different NRC values, and before you specify any material, you will want to make sure you find its specific NRC value to ensure you will get the performance you desire. As we look at the chart, you'll see various building products and their typical NRC ratings. As you can see, the type of material has a major impact on the NRC rating and acoustical performance. Thin pile commercial carpets provide some sound absorption with an NRC of around 0.25. However, many facilities such as museums, hospitals, restaurants, or gymnasiums do not include carpet. They tend to utilize tile or even finished concrete. One thing we are seeing is that many open office plans spaces are moving away from carpeting as well. This further contributes to the overall noise level, as hard surfaces like tile promote reverberation rather than inhibit it. When you look at the fibrous insulations like fiberglass and mineral wool, you'll generally find that they have high NRC ratings. For example, many fiberglass products have NRC ratings from 0.65 to 1. One thing to note is that the density and thickness of material also impacts the NRC. The insulation's properties like thickness and density play a substantial role in its ability to control sound. A higher density or thicker insulation can increase the sound absorption, especially across lower frequencies. The chart on the left shows how increasing the density of a fiberglass product can improve the sound absorption. The curves shown are for material at a certain density in pounds per cubic foot. As the density of the product increases in the curves from right to left, you can see that the NRC increases at certain frequencies. The chart on the right shows the same thing, but with a change in the thickness. Moving from a 1-inch product to a 2-inch or 3-inch product can increase the NRC significantly. Increasing the thickness of a fibrous insulation will generally have the greatest impact on sound absorption performance over increasing the density, though both material properties do impact performance. Keep in mind that sound control isn't just a nice-to-have feature in a building. Building standards that we generally associate with energy efficiency and sustainability, like LEED or the WELL building standard, also make note of acoustical control requirements for specific room types. You can see that for the WELL building standard, minimum NRC ratings of 0.9 and 0.8 are given for open office and conference spaces respectively. These values are for ceilings, and additional sound absorption products on the walls may be required to meet these requirements depending on the layout and size of the room. The T60 guidelines you see under LEED are another type of sound control measurement. The T60 measurement is a reverberation time, or the time required for the sound level to decrease 60 decibels. Equations can be used to convert between NRC and T60 measurements. So now that we've got a good idea of what sound control looks like, let's talk about sound control in office spaces. With the increase in open plan office environments, there's a lot of discussion on the impacts to productivity. Evidence regarding links between noise and workplace productivity suggests a trend to reduced employee satisfaction. Recent studies have shown that intermittent speech, something commonly encountered in an open office space, can negatively impact productivity more than continuous speech or a non-speech noise. While this isn't terribly surprising for anyone who has ever worked in this environment and knows firsthand how many distractions there can be, this is still a relatively substantial negative to open office spaces. Other sounds often encountered in open office spaces, like background music, have been found to be helpful in some cases, like sports performance, but can also be disruptive to reading. White noise, or sounds that mask other sounds, can also be used to combat these distractions. However, these systems can be difficult to implement and maintain successfully. The bottom line is that studies have shown that people are most productive when they are in a quiet environment, and even that silence is the best for accuracy and productivity. So, since we all know that silence is not an option in an office, much less an open office, what are some of the ways to control noise levels? In the next several slides, I'll be reviewing some of the advantages of utilizing stylized insulation to lower the overall noise level. This comes in the forms of acoustic wall panels, clouds and baffles, office partitions, and ceiling tiles are the tools we'll be discussing specifically. As you will see, in addition to improving the noise levels, these products can add to the aesthetic appeal of the space. Acoustic wall panels are an easy way to improve the acoustics in a room. The first photo shows an example of an insulation board wrapped in a fabric. In this example, the fabric is adhered to the insulation board. However, in some systems, fabric is actually stretched over the insulation material to give it a specific appearance. The insulation provides the sound control, and, as discussed previously, added insulation thickness can improve the performance of these systems. There are many different fabric options that provide attractive finishes. There are also options for unique printed designs and shapes, and these systems come in a wide range of colors. I've seen custom acoustic wall panels utilizing company colors or incorporating school logos to bring in a unique overall feel to the space. Acoustical wall panels are easy to install. In some cases, they come with hanging clips already attached. These products are very durable, and there are even products designed for high-impact areas. They are an inexpensive way to improve both the sound control and aesthetics of the space. Office partitions historically have been one of the most frequently used products to reduce noise in an office environment. They can provide some privacy and improve sound control for improved productivity. There are many different design options as well as a wide range of fabric colors. As with acoustic wall panels, the fabric may be bonded directly to the insulation or may be stretched over the insulation depending on the office partition design. These systems can also provide functional elements such as a tackable or writable surface, and they can complement desk and other office design features. Historically, office partitions, or cubicles, were used extensively in office spaces. With the shift to open office designs, the size of the office partitions has shrunk, and thus the amount of material to absorb sound has been severely reduced. With this, other acoustical control methods are needed. One of the most common products used for acoustical control are ceiling tiles. There's a wide selection of material available with varying NRC ratings. The most common system includes a grid system hung above the office space, where the ceiling panels fit into the channels of the grid. Design trends are including more customized looks, such as the curved ceiling designs that you see on the picture on the lower right. And there are many different material options available for ceiling tiles in general in office spaces. If the office design doesn't include ceiling tiles, baffles and clouds are another excellent choice to control noise. These products have similar benefits to acoustical wall panels, but can be utilized throughout an office space. The unique designs, shapes, sizes, and colors available offer an infinite amount of creative choices. Many of the cloud and baffle designs include factory-installed attachment hangers, which make them easy to install with adjustable hanger wires. The spacing of the baffles should be considered if the optimal acoustical control is desired. This gets confusing with the different sizes and shapes of baffle and cloud designs. Technical product literature from manufacturers, or in some cases working with an acoustical consultant, can help with the recommended number of baffles or clouds and the appropriate spacing. As with acoustical wall panels, baffles and clouds are an inexpensive way to improve both the sound control and aesthetics of a space. In addition to the thermal performance benefits of fiberglass, these materials are excellent sound absorbers. They are among the most widely used acoustical material in a wide range of applications. Fiberglass products are lightweight, which makes them easy to handle on the job site, and they come in a wide range of density and thickness options. They can also be very economical versus other products such as foam materials. They provide excellent corrosion and mold resistance, as well as low fire and smoke properties. Finally, products utilizing fiberglass materials are easy to fabricate and handle for the installer. There are many economical sound control insulation options that can have a high aesthetic impact. As you can see in this photo, combining the various products we've discussed can give any space a unique look and feel. Many manufacturers even offer custom printed images for the finished surface of acoustical wall panels. And in addition to traditional office spaces, these products can be used for many different spaces, including movie theaters, recording studios, churches, museums, home theaters, or schools. As you look at designing interior spaces, don't feel like you are limited to one design because the insulation doesn't meet your needs. As you've seen in this deck today, there are a myriad of insulating options out there that can help meet the unique aesthetic design requirements of your application.